Very good morning. Theory of computation. In theory of computation, we are going to discuss about normal forms. So in normal forms, first we should know what is meant by context-free grammar. Let me define what is meant by context-free grammar. In context-free grammar, we'll define G is equal to V, T, P, S. V is for variables, T, terminals, P, production, S, start symbol. Okay. Now, in context-free grammar, how are we going to convert a particular context-free grammar into Chomsky normal form? So, we should know what is meant by Chomsky normal form. We call it as CNF. So, the definition for Chomsky normal form is any grammar G can be called it as CNF. When we call this particular grammar as CNF, if any of the production has the form A tends to BC or A tends to A, then we call this grammar as Chomsky normal form. Any of the production which has either this form A tends to BC or this form A tends to A, we call it as Chomsky normal form. So, what is the rule over here? In left hand side of the production, only one variable, and in the right hand side of the production, we can have two variables. So, which is in capital letter, we call it as variables. Here, when we say A tends to A, smaller A, then in right hand side of the production, if there is a terminal, it must be only one terminal. This terminal can be either small a, small b, 0, or it can be 1. So this is the definition for CNF, Chomsky normal form. Now let us discuss how to solve the problem, how to convert any context-free grammar into CNF, Chomsky normal form. So the grammar is S tends to 0, A, B, 0. A tends to 1, A, 1, 1. B tends to 1, B, 1. This is CFG. We need to convert this CFG into CNF. We know the definition for CNF. It is A tends to BC or A tends to A. Now, what is the procedure to convert any context-free grammar into CNF? First and the foremost thing is, in our given grammar, we need to check, is there any epsilon production or is there any unit production? Epsilon production in the sense, whether your grammar has epsilon symbol. If there is an epsilon symbol, we need to eliminate it. Suppose, if your grammar has unit production, A tends to B, B tends to C, C tends to D. If any of this form exists in this grammar, we need to eliminate that also. According to the given grammar, there is no epsilon grammar, there is no unit production. We have only normal values. So, now in step 1, what we need to do is, we need to segregate which is in CNF, which is in non-CNF form. So, according to the given grammar, S tends to 0 is in CNF, A tends to 1 is in CNF. So, we will write it over here, S tends to 0, A tends to 1, which is already in CNF. As per the definition of CNF, A tends to A. So, we have written CNF form. Now, we are moving on to non-CNF from the given problem. So, non-CNF is S tends to 0, A, B. A tends to 1, A, 1. B tends to 1, B, 1. So, this is non-CNF production. Now, we have CNF and non-CNF production. This is already in CNF form, so no need to convert it. So, which is not in CNF, there are three production. we need to convert it into CNF form. So what is the procedure? How do we do this? Again, step 2. In step 2, we need to make 3 columns here in step 2, which is not in CNF. First production is S tends to 0AB, A tends to 1A1, B tends to 1B1. In the given question, where you have terminals, terminals are zeros and ones or small letter A and B's. So we have 1 here, 1 here, 1 here. So replace zeros and ones by respective variables. We can choose the variables according to our choice. So this is given production, this is action and resulting production. Resulting production. So what we are going to do is replace 0 by, this is terminal value 0 by B1. Similarly, replace 1 by B2. So we are replacing 0 by B1, replacing 1 by B2. So if we apply this B1 and B2 in the given production, how the grammar is? Let's see. S tends to, instead of 0, we should replace it by B1. So B1 as per the given grammar A, B. Next, A tends to, since we have 1 in the second production, 1 should be replaced by B2. So B2, A, B2. Next, B tends to, in B, 1 means we will replace it by B2, B2, B, B2. So this is what the resulting production is. So in the resulting production, as per the definition of CNF, A tends to BC. In your left hand side, 1 capital letters. In your right hand side, it must be of 2 capital letters. But we have 3 capital letters. So it is not in CNF. So again we need to do the replacement process. Again here also 3 variables. Here also 3 variables. So we need to convert the entire grammar into CNF by further replacement process. How are we going to do in the next step? Step 3. We will write the resulting production over here as a given production to do the further replacement process. S tends to B1, A, B. A tends to B2, A, B2. B tends to B2, B, B2. Now, again we need to do the replacement. Either you can have AB as a combination or B1A as a combination to do the replacement. Let's take AB here, replace AB by D1. Similarly, we'll take AB2, replace AB2 by D2. Again replace BB2 by D3. Right? So our resulting production will be S tends to, we will write B1 as it is, B1. AB will be D1. So D1. Again A tends to, B2 will be as it is. And AB2 is replaced by D2. So D2. B tends to, here B2 will be as it is. And B2 is replaced by D3. So D3. As per the definition of CNF, we have 1 variable in left hand side of the production and 2 capital letters, 2 variables in the right hand side of the production. So the entire problem is now converted from CFG to CNF. Now the final step, we need to rewrite the entire grammar in the appropriate format. How do we rewrite? We know that G is equal to VTPS. So V is all capital letters, whatever we have used in the entire problem. So we know that S, A, B, it is given in the question, and other replacement variables like B1, B2, D1, D2, D3. So B1, B2, D1, D2, D3. These are all variables, and terminals are, which is given in the equation, zeros and ones. Suppose if we have small letter A's and B's, that will be the terminals, but here we have zeros and ones. 0, 1 is terminal, and production. We need to write all the production, whatever we found out till now. We know that S tends to 0 already is in CNF form, and the final converted form for, that is CNF form for S, A and B, we need to include in our new production. So here B1, D1, and then A tends to, already we have 1, along with 1 we have B2, D2, B tends to B2, D3. Apart from this, all the replacement functions, B1 tends to 0, B2 tends to 1, and we need to include this AB. D1 tends to AB, D2 tends to AB2, D3 tends to B2, and S is the start symbol. So, as for the question, the entire grammar CFG is converted into CNF. According to the definition, it is proved.